Hello everyone, we are Group 3 and today's presentation is on plate heat exchanger. Some of the things we will be discussing in this presentation are 1. What plate heat exchangers are, and then we'll move on to talk about how we can apply the first law of thermodynamics to plate heat exchangers. And then we'll talk about the working mechanisms and flow arrangement of plate heat exchangers. Then lastly, we'll talk about advantages and disadvantages of plate heat exchangers. Then we'll add the applications of plate heat exchangers. Alright, now let's explain what plate heat exchangers are. So a plate heat exchanger is a type of heat exchanger that uses metal plates to transfer heat between two fluids. The heat exchanger is an open system. We all already know what an open system is. An open system allows both mass and energy to cross its boundaries. The plate heat exchanger qualifies to be an open system because it allows fluids to continuously enter and exit the exchanger. The system operates under steady conditions, meaning the mass flow rate equals the mass flow rate in equals the mass flow rate out for both fluids. Now we move on to talk about types of plate heat exchangers. So we have about 4 types. The first one is gasketed plate heat exchangers. We also have brazed plate heat exchangers. The next one is welded plate heat exchangers. And then we also have semi-welded plate heat exchangers. So let's briefly explain what these types are. So a gasketed plate heat exchanger. These exchangers use high quality gaskets and designs to seal plates together and protect against any leaks. You can remove plates easily for cleaning, expansion or replacing purposes, which helps reduce maintenance costs. Now let's explain brazed plate heat exchangers. They are used in many industrial and refrigeration applications. These exchanges can be very efficient and compact. This tends to make them a highly economic choice. If you are using a stainless steel plate with copper brazing, this dynamic can be highly resistant to corrosion. Let's explain welded plate heat exchangers. So these types are very similar to gasketed heat exchangers, but the difference is the welded plates can be attached together. They are very durable and are ideal when it comes to transferring fluids with high temperatures or corrosive materials. Okay, so let's explain the last one, which is semi-welded plate heat exchangers. These types, it features a mix of welded and gasket plates. The two plates are welded together and gasketed to other pairs within the heat exchanger. This results in an easy to service heat exchanger, and you are able to transfer more fluids throughout the system. Semi-welded heat exchangers are great for transferring expensive materials due to their low risk of fluid loss. This image shows a schematic of a shell and tube heat exchanger. This is also an image of a fusion bonded plate heat exchanger. This is also another type of fusion bonded plate heat exchanger. and then we have brazed plate heat exchanger. So now we are moving on to relate thermodynamics to plate heat exchangers. So we have the energy balance equation according to the first law of thermodynamics, which can be expressed as Q is equal to mCp delta T, where Q is equal to heat transferred, M is equal to mass flow rate, Cp is equal to specific heat capacity, and then delta T is equal to temperature change. Okay, now the first law of thermodynamics for an open system relating to a plate heat exchanger can be expressed as Q with a dot on top minus W with a dot on top is equal to M multiplying H out minus H in, where Q is equal to heat transfer rate and then the W is equal to work done, and the H out minus H in is equal to the difference between the specific enthalpies at the output and input. Since a plate heat exchanger does not perform work, the work done will go to 0, and then the equation will simplify to Q is equal to M multiplying H out minus H in. This equation confirms that heat transferred whilst mass flows through, and this makes it an open system. Okay, now so we are going to explain how the plate heat exchangers work and their flow arrangement. So let's start with how it works. The main functionality of a heat exchanger is to transfer heat between two fluids at different temperatures. Most exchangers consist of a coiled pipe that allows one fluid to pass through a chamber which holds another fluid. The pipe's walls are metal or another substance containing a high thermal conductivity to enable the interchange of heat. The chamber in which the pipes are held are made out of plastic or coated with thermal insulation to keep heat from escaping. Many of the most popular types of heat exchangers used in the mechanical industry consist of shell and tube, air-cooled plate and frame. Many plate heat exchangers are made of corrugated plates on a frame. This creates high turbulence and high wall shear stress, resulting in a high heat transfer and a high fouling resistance. So now let's talk about the flow types. The flow types, there are two types. The first is counter flow and the second one is parallel flow. So the counter flow is more efficient because it transfers heat better. The parallel flow is less efficient, but it is used in specific applications. Okay, now let's talk about some advantages of plate heat exchangers. First, it has a compact size. The plate heat exchangers are designed in such a way that it allows for a large heat transfer area in a small space. Also, another advantage is that it has higher heat transfer efficiency. The large surface area of the plate ensures faster and more efficient heat transfer, and also it is easy to maintain. Why? Because the plates can be easily removed to be cleaned, repaired, or maintained. So now we move on to talk about disadvantages of plate heat exchangers. The first one, it has low pressure capacity. This means that when you want to transfer heat from one fluid to another and the pressures you are using is very high, you cannot use the plate heat exchangers because the the plate heat exchangers has low pressure capacity. Another disadvantage is that fluids containing large particles have the ability to clog the narrow channels between the plates. This would reduce efficiency and increasing pressure drop. Okay, so now the last thing we'll be talking about is the application of plate heat exchangers. Food and beverage industries use plate heat exchangers for sterilization. Also, chemical processing industries use plate heat exchangers for temperature control, condensation, and evaporation of various fluids or substances. Also, pharmaceutical industries use the plate heat exchangers for precise temperature control. This brings us to the end of our presentation.